Hey everyone! So, you just graduated and you're aiming to land that first killer job as a Microsoft Fabric Lakehouse builder? Perfect. You are exactly where you need to be. This explainer is your personal guide to absolutely crushing that technical interview. We're going to break down the key concepts you need to know to really impress your future boss. And hey, just so you know, this isn't going to be a bunch of theory. We're setting you up with all the concepts, but right after this, Rajan is jumping in with a full, hands-on demo for data ingestion with pipelines, so you're definitely going to want to see how this all works in the real world. All right, so here's our game plan. Think of this as your personal study guide for the interview. We'll kick things off with the medallion architecture. Then we'll compare data flows and data factory, get into ingestion patterns, talk about what makes a pipeline production ready, and wrap it all up with your next steps. Let's dive in. First up, let's talk medallion architecture. You know, interviewers almost always start high level. They want to see if you get the why behind organizing data before you get lost in the weeds of how to do it. So, imagine you're in the interview and they hit you with something like this. How do you logically organize data in a lakehouse to ensure quality and structure? This is your moment. It's the perfect setup to introduce the medallion architecture. And honestly, the concept is pretty simple, which is great. It's this three-step journey for your data. First, you've got the bronze layer, where you just dump the raw data exactly as it is, your source of truth. Next up, the silver layer. This is where the magic happens. You clean it, you conform it, you combine it. And finally, you get to the gold layer, which is the polished, curated data ready for analytics and reporting. Each step just makes the data better and more reliable. Now, what's holding all this together, especially in the silver and gold layers? That's Delta Lake. It's really the standard in Fabric. And you want to mention it because it's what brings things like ACID transactions to your data lake, which basically just means it's what makes the whole lakehouse reliable and trustworthy for huge data sets. Okay, so we've nailed the architectural why. Now let's get into the tooling what. This is a classic interview question, right? Choosing the right tool for the job. The big one here is knowing the difference between Dataflow's Gen 2 and Data Factory pipelines. Think of it like this. Dataflow's Gen 2, that's your go-to for low-code data prep. It's perfect for business analysts who live in tools like Power Query. Data Factory, though, that's the heavy hitter. It's the enterprise-grade tool built for data engineers who need to handle complex orchestration and heavy-duty ETL. This table right here, this is basically your cheat sheet for the interview answer. You'd go with Dataflow's Gen 2 when, say, you need some quick, low-code shaping, when business analysts are prepping their own data, or when you're working with smaller datasets from places like Excel or SharePoint. But you're going to reach for Data Factory when you're building serious enterprise-level pipelines, when you need complex orchestration from massive datasets, or when you need to bring in things like Spark notebooks. Knowing this shows you think like a real architect. All right, enough theory. Let's get practical. This next part is all about data ingestion patterns. This is where you really show them you know the how, that you can actually build stuff that works efficiently. So to talk about loading data efficiently, you absolutely have to bring up the idea of a watermark column. It sounds technical, but it's not. It's just a column in your source data, like a timestamp or an auto-incrementing ID, that always goes up as new stuff gets added. It's the secret sauce for tracking what's new since the last time you loaded data. And using that watermark is like a simple four-step dance, super easy to explain. First, you grab the last watermark value you stored from the previous run. Second, you look at the source and get the new current watermark value. Third, and this is the key, you only copy the data that falls between those two watermarks. And fourth, you save that new watermark value for the next time. It's so much smarter than reloading everything every single time, right? Okay, this is where you go from being a good candidate to a great one. I mean, anyone can talk about moving data from point A to point B, but you're going to show them you have enterprise awareness. You think about building pipelines that are ready for the real world, scalable, reusable, the whole shebang. A huge part of that is monitoring. You can't just build a pipeline and walk away, right? You got to track its progress, catch problems early, and just make sure everything is running smoothly. In Fabric, you'll want to mention the monitoring hub. Talking about this shows you think about the pipeline's entire life, not just day one. And here's a great way to put this, even for a non-technical HR person. Monitoring helps you stay in control so you can catch problems before they grow. See? It connects the tech task directly to business value, which is all about reliability. Another pro tip, talk about parameters. This is huge. Instead of hard coding stuff like a server name directly into your pipeline, which is a big no-no, you use parameters to pass those values in. It makes your pipelines super flexible and reusable. You can use the exact same pipeline for development, testing, and production just by feeding it different values. Interviewers love to hear this. And to really round things out and show you're up to date, you can drop a mention of CI/CD. This shows you're thinking like a modern developer. In Fabric, you talk about using things like Git integration and deployment pipelines to automate how your changes move from your laptop to production. It's all about delivering value safely and frequently. Phew, okay, that was a lot, but we've covered the most important stuff. So let's boil it all down into your final, actionable game plan for that big interview. This is it, your interview cheat sheet. Just remember these 4 things. Number 1, start with the big picture architecture, the why, medallion. 2, know your tools, the key differences between data flows and data factory. 3, get into the practical how by explaining incremental loads. And 4, show your thinking big picture with monitoring, parameters, and CI/CD. If you can speak to these 4 points, you're going to be in amazing shape. And that's our strategic guide. You've got the concepts, you've got the roadmap, and now, to see how it all comes to life, Rajan, it's all yours. Take it away with the demo.
Hi guys. Okay, so let's start the demo. So we are going to create a data pipeline. This is what the data engineers do most of all the time. So we have the data right now. I'll just show you what I have already done. So the new data folder, this is the row files on. So in here we have a file sales.csv. This is what we bring in the data lake. This is the header and this is the data. So to do that, we did it with the pipeline, and this is how we do it. We go to the lake house hub here, and then we say get data pipeline, the name, get raw data. So it automatically starts this copy wizard to help us copy the data. I mean, if we are copying the data from GitHub or some HTTP location, we say search for HTTP and then select HTTP and then walk through this wizard, and then we can it will copy the data. So right now I don't want to go through all the steps again. Because I have already created the pipeline here. I can just show you the pipeline. It will create this particular one, copy data, and this is how we could have also, like, another way to get the data was we could have used it without the pipeline. If we didn't create the pipeline, we could have just said upload and files. This is like uploading from uploading to Google Drive kind of thing. But right now we went through the wizard and created the pipeline. So then, so once that pipeline is created, to transform the data, what we did is we went here, created a notebook, a new notebook, and then this is the notebook. So the important thing here to see is that in the notebook we have defined a parameter here. So the first cell here is a parameter. Table name is a parameter. Right now we have given a dummy name here, dummy value cells. And second cell, what we are doing here is like we are reading the file that we copied in the row zone, this file from here. Then we added month and year columns. We added first name, last name, we derived. We filtered and reordered the columns. So all the ETL we did here, all the transformations. And then we said load the data into table. Finally, we load into the delta format. So this is the delta format here. So how we did it, how we do now, we need to run this through the pipeline. So what we will do is we'll attach this notebook as part of one, as one activity inside the uh, pipeline. Okay, so this notebook run will be an activity inside the pipeline. So this is what we have done here. Earlier it will be like this one, only the copy, then we modified it. So what we did is like we added delete data activity, and then we added notebook activity. So like this one, say we are here for example, then we'll just say activity, then we'll delete. So we did the delete activity, then we'll copy the data. So this is basically, this is how we connected all that, and we did all these settings in this settings tab and other tabs, and then we run the notebook. So we say notebook, connected the notebook here to completion. So this is how we modified the previously created pipeline. It was created by the copy wizard. So this is how we connected it here. And then the important part here was in the notebook, we have defined the parameter. Now in the settings, in the base parameter, we say table name. This is the parameter inside our notebook, which is here, table name. This parameter value, we don't want it to be cells, we want it to be something else. Then we will define it here. So new cells, for example. Right. So then this is how we will define it. And then once, let's say, settings, we say new cells data. And then we save it. We run it. So basically the way the setup is done is we are deleting the old files first, then we are doing the copying. So we are running that copy activities, we are copying the file, and then we are running the notebook. And as we run it, it shows first the output here, like first activity is complete. So the parameter setting is very important, and that's what is discussed in detail. It's nicely explained after the demo in the interview practice session after this. Okay, so all these three activities ran successfully here. So now if we go back to the lake house here, we can refresh this. This was our old table, not this one. So this time we created this, we passed this as a parameter name. So we got this one. So this is our table in which we put our transform data here. So this is what usually happens in the Medallion architecture as well. Like we are putting first in the row zone, or whatever we call it, bronze, then silver. The transform data will go here, and then from the transform data we will put it into the analytic ready, like star schemas. So in another tables we will transform, we'll put it again, transform it again. We'll do the ETL same way we use in the notebook. So yeah, this is how most of the data engineers will be doing this ETL using the notebooks and all. Okay, thank you.
Thanks, Rajan, for providing the hands-on demo. That walkthrough was absolutely essential for what we are about to cover today.
It really was. I mean, it's one thing to see these things in, an architectural diagram, but seeing the actual button clicks, seeing the interface, it just changes the whole conversation.
Welcome back to the deep dive. Today is going to be a massive one. We're doing something a little different, something really special that's tailored for a very, very important part of our audience.
Yeah, this is a fun one.
We're talking to the fresh data science graduates, the ETL engineers, the people who are staring at job descriptions right now and realizing the whole game has changed. We're zeroing in on the role of the Microsoft Fabric Lakehouse builder.
It's such a fascinating time to be getting into this field. The tooling has just shifted so dramatically in, the last 18 months. If you're going into an interview today with knowledge from even just 3 years ago, you're going to have a hard time.
Exactly.
But the material we've got here, these docs, the guides, it's basically the answer key for the test.
That is precisely how I want to frame this. The whole goal of this deep dive is to get you through the hour of power. You know what I mean by that.
Oh, I know exactly what you mean. The technical screen.
The technical screen. You get past the recruiter, the initial vibe check call, and then you're on a Teams call with a senior architect or a lead engineer. And for 60 minutes, it's just a drill. They want to know if you actually get how this stuff works under the hood.
They really do.
So our mission today is to synthesize the answers that won't just get you through that hour, but will genuinely impress the person on the other side of the virtual table.
And, I mean, having been on that other side of the table many, many times, the difference between a candidate who's just memorized a few definitions from a blog post and a candidate who truly understands the life cycle of the data, it's just night and day.
So we want to help you become that second candidate.
Exactly.
Okay, so here's how we're going to structure this. We'll follow the data's journey, right? Start with the architectural foundation, the big picture, and we'll get into tool selection, because I feel like that's a trap waiting to happen.
Classic trap question, yeah.
Then ingestion, the nitty-gritty of getting data in, then the really complex stuff, transformations, and finally the operational side, CI/CD, monitoring, and maybe most importantly, cost management.
Cost management is the sleeper topic. If you can walk into a technical interview and speak intelligently about the financial implications of your architectural choices, you are already in the top, 10% of candidates. Instantly.
I love that. Okay, let's set the stage. For this whole deep dive, I'm the learner. I've read the docs. I've clicked around in the trial, but I need you to connect the dots for me. You're the hiring manager. I'm in the hot seat.
All right, let's do it. I'm ready.
Okay. Section 1, the architectural foundation. I sit down. I'm a little nervous. You look at me, and you ask that first huge fundamental question. How do you organize data in a lakehouse?
And this is the litmus test. It really is. If your answer involves talking about, a bunch of random folders, or we just dump it all in one big table, the interview is, for all intents and purposes, over.
So what's the right answer?
The industry standard, and specifically the design pattern that Microsoft is pushing hard for Fabric, is the medallion architecture.
The medallion architecture. Bronze, silver, gold. I see this on every single slide deck, every conference talk. But let's get past the buzzwords. What are we actually building when we say medallion?
Okay, the best analogy I've ever heard for it is a water treatment plant. Think about it. You don't just take raw river water and pump it straight into someone's kitchen sink, right?
Right, of course not.
There are stages: filtration, purification, chemical treatment. The medallion architecture is just that. It's a structured, multi-stage approach to refining your data as it flows through the system.
Okay, I like that analogy. So let's start at the intake pipe.
Yeah.
The bronze layer.
Bronze is the raw zone. And there's one golden rule for the bronze layer that you absolutely have to say in an interview. The rule is immutability.
Immutability, meaning we don't touch it at all.
You never, ever touch it. You store the data exactly as it arrived from the source system. If it came in as a horribly messy JSON file with misspelled columns and nested arrays, you store a horribly messy JSON file. If it's a CSV with a pipe delimiter instead of a comma, that's what you store.
Let me play devil's advocate, though.
Yeah.
As an engineer, my first instinct when I see messy data is to fix it. Why is it so important not to clean it right away?
Because you're human and you make mistakes. We all do. Let's say you write a script to ingest the data and you think, oh, this date format is annoying. I'll just convert it to ISO standard on the fly. 6 months down the line, a bug is discovered. Your script was mishandling time zones and you've just corrupted the dates for millions of records.
Oh, wow.
If you didn't save the raw original, you are completely stuck. There's no way to recover. Bronze is your insurance policy. It's your source of truth. It gives you total auditability. You can always wipe out silver and gold and just rebuild them from scratch, from the pristine bronze layer.
That makes perfect sense.
Yeah.
The master undo button for the entire data platform.
Mm-hmm.
So technically, inside of Fabric, what does that bronze layer look like? Is it just files?
It can be, and that's the flexibility. You can
Yeah.
store the data in its native format, Parquet, JSON, CSV, or you can immediately wrap it in a Delta table for some added benefits. But here is the specific Fabric nuance that will get you bonus points in that interview.
Okay, I'm ready.
You have to talk about shortcuts.
Shortcuts.
Yeah.
This is one of the big selling points for OneLake.
It is massive. Think about the old world, the classic Azure or AWS way of doing things. If your data was sitting in an Amazon S3 bucket or maybe an Azure Data Lake Storage Gen 2 account, and you wanted to use it in your analytics platform, what did you have to do?
You had to copy it, build a pipeline to move it.
You had to copy it. You had to physically move the bits from point A to point B. That takes time. It costs money for the data transfer, the egress fees, and now you're paying to store it twice.
Right, you have storage redundancy you might not even need.
Exactly. Fabric shortcuts are a virtualization layer. It's a game changer. You basically just point one lake at that S3 bucket and say, hey, I want you to treat this external location as if it's a folder right here inside my lakehouse. You don't move the data, you don't copy it. But to all your tools, your notebooks, your reports, it just looks like it's local.
So in an interview, if they mention they have a multi-cloud strategy or data sitting in S3,
You should immediately pivot. You say, well, for the bronze layer, instead of building an expensive, slow ingestion pipeline to copy that data, we can just create a shortcut to that S3 bucket. We can start querying it today with zero data movement. That sentence right there demonstrates you understand efficiency, cost saving, and modern data architecture.
yeah, that's a huge takeaway. So our bronze layer is raw, immutable, maybe even virtualized with shortcuts. Now we're ready to start cleaning. We move to the silver layer.
Silver is the enriched or validated layer. This is where the real data engineering work begins. This is where you do your deduplication. You handle nulls and missing values. Do we drop the row? Do we fill it with a 0 or a default string? This is where you standardize everything.
Standardizing seems like a huge task in a big company.
Oh, it's enormous. Imagine you're a global company. Your U.S. sales system records transactions in USD. Your European system uses euros. Your Japanese system uses yen. You can't do any meaningful analysis on that raw data. In the silver layer, you convert everything to a single base currency. You make sure all the column names are consistent across all the tables. Custod becomes customer ID everywhere. You ensure that a date column is actually a proper date object, not just a string of text that looks like a date.
So silver is clean, it's trustworthy. Is it ready for the CEO's dashboard?
Probably not. Not directly. Silver is usually modeled in what we call third normal form, or at least just as a set of clean, flat tables. It's perfect for a data scientist who needs to dig into the granular row-level details to train a model. But it's not optimized for a Power BI report that needs to load in under 2 seconds.
And that's where the final layer comes in. Gold, the curated layer?
Gold is for the business. Gold is for consumption. This is where you start building your dimensional models, your star schemas. You'll have your big fact tables with all the numbers and your smaller dimension tables with all the descriptions.
And you're pre-aggregating data here, right?
Exactly. If the CFO needs a daily sales by region report, you don't want the dashboard to have to scan billions of individual transaction records from the silver layer every single time someone refreshes the page. Instead, you build a gold table that has the daily totals already calculated and ready to go.
So it's heavily read optimized.
Precisely. That's a great way to put it. Bronze is write optimized for fast ingestion. Silver is about trust and data quality. Gold is read optimized for fast analytics.
Okay, that logical flow is crystal clear. Now, the interviewer leans in and asks about the tech underneath all this. Okay,
Sure.
so you've described the layers. Where does this data physically live?
The first part of the answer is OneLake.
Right. The OneDrive for data.
That's the marketing tagline, and it's a good one. It communicates the idea of a single logical data lake for the whole organization. No more data silos. But the more technical answer, the one that describes the file format, is Delta Lake.
Delta Lake. I see this term everywhere now. It's the default in Fabric. Why Delta Lake? Why not just use standard Parquet files? Parquet is already pretty good.
This is a critical distinction to be able to make. Parquet is a file format, and it's a brilliant one. It's columnar, it has great compression, it's super efficient to query. But at the end of the day, it's just a file. It's dumb. It has no concept of transactions.
What does that mean in practice?
It means if your Spark job crashes halfway through writing a new batch of data to a Parquet folder, you can end up with corrupted data. You might have half-written files, or you might have a situation where a reader comes along and sees an incomplete picture. Delta Lake solves this by adding a transaction log, a folder called Delta Log, on top of those Parquet files.
And that's what gives us ACD transactions.
Yes. Atomicity, consistency, isolation, durability. These are properties we've taken for granted in traditional databases for decades. Delta Lake brings that same reliability to the data lake. It guarantees that every write operation, every transaction either fully succeeds or it fully fails and is rolled back. There's no messy in-between state.
And that log also enables things like time travel, right?
Exactly. Because the log is an ordered record of every single change that's ever happened to the table, you can query the data as it existed at any point in time. It's an absolute lifesaver for debugging. Hey, why did this report number suddenly drop yesterday at 3 p.m.? Well, let's just time travel back to 2:59 p.m. and see what the data looked like.
Now, there's a specific Fabric optimization I want to bring up here. V-order. This feels like one of those keywords that's a secret weapon for an interview.
It absolutely is. If you drop the term V-order into this part of the conversation, you are signaling that you're not just a generic Spark engineer. You're signaling that you are a Fabric specialist.
So what is it?
It's a write-time optimization. It's something that happens automatically when the Fabric compute engines, whether that's the Spark engine or the T-SQL engine, write data to a Delta table in OneLake. They don't just dump the Parquet files. They apply a special sorting, distribution, and compression algorithm called V-order. It rearranges the bits within the Parquet files in a way that is specifically optimized for the Power BI Vertipack engine to read later.
So we pay a very small performance penalty when we write the data
A tiny penalty, yeah.
in order to get a massive speed up when we read the data, especially in Power BI.
That's the trade-off. And since in analytics you typically write once and read thousands or millions of times, it's a fantastic trade-off to make.
Okay, I think that covers the foundation really well. We've got our medallion architecture. It's living on OneLake, and it's built on Delta tables that are being optimized with V-order. Now let's move to section 2, tool selection.
The right tool for the right job section, or as you called it, the trap.
It really feels like a trap because Fabric gives you data flows Gen 2, and it also gives you data factory pipelines. They both move data. They both have data in the name. So if the interviewer asks, which one should I use for my ETL, and I just pick one, am I wrong?
If you pick just one, you're almost certainly giving a junior-level answer. The trap is thinking they are competitors. They're not. They are complementary tools that serve very different audiences and purposes.
Okay, let's break that down. Let's start with Data Flows Gen 2. Who is this for?
This is for the data analyst, the power user, the
Yeah.
citizen developer. The core technology inside Data Flows Gen 2 is Power Query. If you've ever used the Get Data experience in Excel or in Power BI Desktop, you already know Power Query. It's that visual, step-by-step, low-code interface.
So it's great for data wrangling. If I need to split a column or pivot some data or, merge a couple of tables from a SharePoint site.
Data flows is perfect for that. It excels at those kinds of data shaping and preparation tasks. It's fantastic for small to medium data volumes and for enabling self-service analytics. It has hundreds of connectors to business applications, SharePoint, Dataverse, Dynamics, Salesforce, things that engineers might not want to deal with.
Okay, so that's the analyst friend. What then is the data factory pipeline?
The pipeline is the engineer's powerhouse. It is first and foremost an orchestration engine.
Orchestration. Let's define that term in this context.
It means the pipeline's main job isn't to process the data row by row itself. Its job is to manage the flow of a larger process. A pipeline says, first, call this REST API, then copy this massive file from A to B. If that copy activity succeeds, then trigger this Spark notebook to run. But if it fails, send an alert email to the support team. It's all about control flow loops, if-then-else conditions, variables, parallelism, and it is built for massive scale. When you're talking about moving terabytes of data, you use a pipeline.
So, the senior engineer's answer isn't to pick one over the other.
No. The senior engineer's answer is to describe the better together pattern. You use both.
Okay, walk me through a typical workflow using that pattern.
Let's take a standard ingestion process. You would use a pipeline for the extract and load part, the ETH and the L of ETL. You'd use the copy activity within the pipeline to grab the huge raw source data and just dump it into your bronze layer. Why? Because the pipeline's copy activity is highly optimized, fast, and cost-effective for just moving bits.
Okay, so the heavy lifting, the raw data movement, is handled by the pipeline.
Right. Now the data is sitting in your bronze layer, but it's still raw and messy. Now you need to do the T, the transformation. You need to clean it and get it into the silver layer. For this part, your pipeline might call a data flow Gen 2. Why? Because maybe the business logic for cleaning the data is complex, but the visual interface of Power Query makes it really fast and easy for an analyst to define those steps without writing code.
So the pipeline is the overall controller.
The pipeline is the conductor of the orchestra. The data flow, or maybe a Spark notebook, if the data volume is huge, is one of the musicians playing a specific instrument. The pipeline tells it when to play and what to do with the result.
That is a fantastic analogy. Conductor and musicians. I like that. Okay, let's move on. Section 3. Ingestion mechanics. We have to actually get the data in, and here's a scenario that I know comes up in almost every interview because it's a real-world, everyday pain point. The on-premises challenge.
Ah, yes.
Yeah.
The server in the basement.
The server in the basement. The interviewer says, "We love the cloud, it's great, but our most critical system, our ERP, is running on a SQL server in the basement of our headquarters. It's behind a very strict corporate firewall. How do we get that data into Fabric?"
The first thing to say is that you can't just use a connection string and hope it works. The cloud, by design, cannot reach into your private secure network. You need a bridge. And in the Microsoft ecosystem, that bridge is the on-premises data gateway.
What is that gateway? Physically, is it a hardware box?
No, it's just a piece of software. You download an installer from Microsoft and you install it on a server, a machine that is inside your local network. It has to be on that same basement network as a SQL server.
Right.
It just sits there running as a Windows service and acts as a secure messenger.
Now, this is where we need to get into the details that prove I've actually done this before. Anyone can say, install the gateway. What's the technical detail that proves I know what I'm doing?
The firewall rule. This is the big gotcha for most companies. The gateway does not require you to open any inbound ports in your firewall. You don't have to punch a hole to let the internet in, which would be a security team's absolute nightmare. It works by making secure outbound connections to the Azure Service Bus.
And is there a specific endpoint we need to whitelist for that outbound connection?
There is. You need to tell the network team to allow outbound traffic on port 443 to the address .frontend.clouddatahub.net.
Okay, let me repeat that. .frontend.clouddatahub.net. If I say that specific URL in an interview.
The person interviewing you is going to sit up a little straighter. They will know you've been in the trenches and have actually configured this in a real locked-down enterprise environment.
There's another constraint with the gateway that I think trips people up. Once it's installed, can I just browse the file system of the server it's on from my Fabric pipeline?
Not directly, no. And that's a key security feature. A lot of junior folks think, oh, the gateway is installed on that server, so I can just point my pipeline to dataimportantfile.csv. It doesn't work like that. Inside the Fabric service, you have to explicitly create a connection resource. You tell that connection which gateway to use, provide the credentials, and then it validates. The gateway acts as an isolation boundary. You can't just freely roam around the on-prem network.
Okay, so the gateway's installed, the firewall rules are set, the connection is configured, the tunnel is open. Now we actually need to move the data. We'd use a pipeline, and inside that, the copy data activity.
The copy data activity is the workhorse of Data Factory, and you can launch it from a simple wizard in the Fabric UI. It walks you through it. Pick your source, pick your destination, map the columns.
But it's more than just a simple file copier.
Yeah.
Right? It has some intelligence.
Yes. Oh, absolutely. It's very powerful. It can handle column mapping, so you can rename columns on the fly as the data moves. It can handle data type conversions. And most importantly, for large data sets, it has built-in modes. You can do a full, complete copy of a table, or you can configure it for incremental copy.
We're definitely going to double-click on incremental copy in a bit because that feels like a huge topic on its own. But first, let's talk about where the drag-and-drop tools run out of steam. Section 4. Advanced logic.
Right. This is where we leave the citizen developer world behind and put on our engineering hats.
The interviewer throws you a curveball. I need you to take this column of customer comments and run it through a sentiment analysis model using a custom Python library. Or, we have this proprietary binary file format from our lab equipment. You need to parse it. The copy wizard can't do that.
No, not a chance. For that kind of custom, complex logic, you need notebooks.
Spark notebooks.
Exactly. Fabric comes with a fully managed, serverless Spark engine. You can write code in Python, Scala, R, or SQL directly in a notebook interface. This gives you, effectively, infinite flexibility. If you can express the logic in code, you can execute it in Fabric.
But we're not just running these notebooks manually by clicking a run button, right? We need to automate them. Talk to me about the handshake between a Data Factory pipeline and a Spark notebook.
This is the absolute standard pattern for any robust production-grade lakehouse architecture. Think about that lab flow we looked at earlier. It's a perfect example. Step 1. The pipeline starts, and its first activity is delete data. It cleans up a landing zone to make sure the process is idempotent, that we're not accidentally processing old files from a previous failed run.
Good hygiene.
Crucial hygiene. Step 2. The pipeline runs a copy data activity. It grabs the new raw file from the source. Maybe it's an HTTP endpoint, maybe it's from on-prem via the gateway, and it lands that file in the file section of the lakehouse.
So at this point, the raw file is sitting in OneLake storage, but it's not actually a table that I can query with SQL.
Exactly. It's just a file, like a CSV or JSON sitting in a folder. So, step 3. The pipeline executes a notebook activity. It effectively hands control over to the Spark engine. The notebook spins up, its code runs, it reads that raw file from the files section. It applies all that complex Python logic, the parsing, the sentiment analysis, the heavy mathematical calculations, and then it writes the clean, structured result out as a proper managed Delta table.
So again, the pipeline handles the logistics of moving and sequencing, and the notebook handles the complex business logic.
Correct. But now, here comes the aha moment, the thing that really distinguishes a junior engineer from a senior one in an interview, and that is parameterization.
Explain what you mean by that.
Okay, a junior engineer gets a task to process the sales data. They write a notebook called processsalestable.ipymb. And inside the code, they hard code the file names. df is equals spark.read.load, landingsales.csv. Then they get a task to process customer data. So they copy that notebook, rename it processcustomerstable.ipymb, and change the file name in the code to customers.csv. If you have 100 tables to process, you end up with 100 nearly identical notebooks.
Which is a complete and utter maintenance nightmare.
It's a disaster. A senior engineer writes one notebook, let's call it generic file totableprocessor.ipynd. And inside that code, they don't hard code any file names. They use variables, something like source file, default.csv, and targetable, defaultable.
Okay, but how do you get the pipeline to change the value of that variable at runtime?
This is the key trick. In the Fabric Notebook interface, you go to the cell where you declare those variables. In the cell's toolbar, there's a little toggle switch or an option that says toggle parameter cell. You click that. This adds a parameters tag to the cell's metadata. This is how you tell Fabric, hey, the variables in this specific cell can be overwritten by an external caller.
Ah, okay. And then in the pipeline, on the notebook activity itself.
In the pipeline, when you configure the notebook activity, there's a Settings tab. And on that tab, there's a section called Base Parameters. You'll see a little table where you can add parameters. You type in the name of your variable from the notebook-like source file, and then in the value field, you can pass in a dynamic value from the pipeline.
So I could have a pipeline with a for each loop that iterates through a list of 100 table names. And on each iteration, it calls that same generic notebook. just passing in a different source file and targetable parameter each time.
Exactly. You write the core processing logic once, and you reuse it across the entire enterprise. That is scalable, that is maintainable, that is senior-level architecture.
That is absolutely the answer that gets you hired. Okay, speaking of passing dynamic values, we have to get into the weeds of the syntax. Section 5, Deep Technical Dive, the pipeline expression language.
This is the glue that holds all the dynamic behavior together. And it's important to state that it's not Python, it's not C#, it's not SQL. It's its own specific JSON-based expression language that Data Factory uses.
Okay, so the interviewer asks a basic syntax question. I want to create a folder path for my output that includes the current date. How do I do that dynamically? What's the syntax?
The magic symbol you need to know is the @ sign, @2. And specifically for embedding expressions inside a string, you wrap it in curly braces. @tier.
Give me an example for that date folder.
So instead of typing a static path like output 22.4 EO2 or 4, you would use an expression. You'd type something like @concat output format datetime URR MMDD. The pipeline engine evaluates that expression at runtime and replaces it with the actual current date before the activity runs.
What about referencing the output of a previous step? Let's say I have a lookup activity that queries a control table to get a file name, and I need to pass that file name to the next activity.
The basic syntax for that is activity.output.field. So it'd be something like @activity get file name lookup.output.firstrow.filename.
It seems pretty straightforward. Activity.output.
It is, but it can get a little tricky. If the field name you're trying to access has a space in it, like file size, the dot notation will fail. In those cases, you have to switch to using square bracket notation, just like in JSON. So it would become activity get metadata.output file size.
Got it. And what about system variables? Let's say for logging purposes, I want to capture the unique ID of this specific pipeline run.
That's a great one to know. It's @pipeline. And you're right, you should be logging that for every major operation. When something fails at 3 a.m., that run ID is the breadcrumb you use to trace everything that happened in that specific execution.
Okay, knowing that syntax is clearly critical for the technical screen. But now we arrive at what I truly believe is the boss-level question of any data engineering interview, the incremental load pattern.
This is the big one. This is what separates a proof of concept or a toy project from a real production-scale data warehouse.
The interviewer sets the scene. Our source database has a 10 terabyte sales table. We cannot copy the whole thing every night. It would take 12 hours and cost a fortune. How do you design a pipeline to copy only the new or updated records since the last run?
The answer you need to give is that you would implement a watermark strategy.
Okay, let's walk through this step by step. Imagine I'm at the whiteboard with a marker. What's step 1?
Step 1. Identify the watermark column. Before you can write a single line of code, you need to find a column in your source table that can tell you what's new. This is usually a timestamp column like last modified time or creation date, or sometimes an auto-incrementing integer ID. If the source table doesn't have a reliable column like this, you have a much bigger problem, but let's assume for the interview that it does.
Okay, so we found our last modified time column. What's next?
Step 2. Create a watermark storage table. You need a place to remember where you left off last time. So in your data warehouse or lakehouse, you create a very small table. Let's call it dbo.watermarkable. It might just have 2 columns, table name and watermark value. This table will store the timestamp of the last successfully processed record.
So it's like putting a bookmark in a book. Last time, we read up to page 256.
That's a perfect analogy, exactly. Now for step 3, the pipeline logic. This is a specific sequence of 4 activities. First, you use a lookup activity. Its job is to query your local dbo.watermarkable to get the old watermark.
So it's asking, where did we put the bookmark last time?
Precisely. Second, you use another lookup activity. This one queries the source system to get the new watermark. You'd run a query like select max last modified time from source sales table.
And this one is asking, what's the last page in the book right now?
You've got it. So now your pipeline has 2 variables. The old watermark and the new watermark. You have your 2 bookends. The third and most important activity is the copy data activity. In the source settings of this activity, you don't just select the table. You switch to query mode and you write a specific SQL query. It looks like this. Select from source sales table where last modified time at variables old watermark and last modified time at variables new watermark.
Oh, there it is. That's the magic. You're not copying the whole table. You're just surgically selecting the slice of data between the old and new bookmarks.
Exactly. Instead of moving 10 terabytes, you might only be moving 10 megabytes. It's a massive difference in performance and cost.
And after that copy is done, are we finished?
No. And this is the step where so many people fail the interview question. You've moved the new data, but you haven't moved your bookmark. If the pipeline stops now, the next time it runs, it will use the same old watermark again and recopy all the same data.
So you need a fourth step.
You need a final fourth step. Usually, this is a stored procedure activity or a script activity. Its only job is to run an update statement against your debo.watermarkable and set the watermark value to the new watermark you captured in step 2.
And you only do that after the copy activity is successfully completed.
That is the crucial part. The pipeline is sequential. If the copy activity fails for any reason, the pipeline run will error out. That final stored procedure activity will never run. This means your bookmark stays at the old value. The next time the pipeline runs, it will automatically reattempt to copy that same failed slice of data. It ensures zero data loss.
That pattern is just brilliant. It covers orchestration, dynamic SQL, failure handling, efficiency. It's everything in one.
If you can clearly and confidently draw that 4-step process on a whiteboard, you are getting hired, period.
Okay. We have built the architecture, ingested the data, handled the complex logic, and optimized the load. Now we need to live with this thing. Section 6, operationalizing. Day 2 operations.
The fun part is over. Now we have to support it in production.
The interviewer asks, your pipeline is scheduled to run every hour. How do you know if it failed? I'm not going to sit there and refresh the web page all day.
The first place you go is the monitoring hub within the Fabric workspace.
And what am I looking for in there? Just a list of successes and failures.
That's there, but the most powerful tool for debugging is the Gantt view. When you click into a specific pipeline run, it shows you a visual timeline. It looks like a project management chart, with bars representing the duration of each activity.
Right, so you can see how long each step took.
Not just that, you can see the dependencies and the parallelism. It's the fastest way to spot a bottleneck. If the bars for your 2 lookup activities are tiny little slivers, but the bar for the copy data activity is a massive long bar, you know instantly where your performance problem is. Why is this copy taking 20 minutes?
But what if I need to do more advanced monitoring? I'm a developer. I want to write a query. Show me the failure rate of all pipelines tagged critical over the last 30 days.
For that, you need to go a level deeper. You need workspace monitoring. You can configure your Fabric workspace to send all its diagnostic and operational logs to an external store, like a log analytics workspace, or, more natively now, a KQL database.
KQL is the Custo query language.
Yes. And if you want another keyword to impress the interviewer, there is a specific table where all this data lands. It's called Item Job Event Logs. Knowing that table name shows you've gone beyond the UI, you can write powerful KQL queries against that table to build custom monitoring dashboards for failure rates, long-running jobs, cost analysis, whatever you need.
Speaking of keeping things running smoothly as a team, let's talk about CI/CD. The HR manager or the engineering lead asks, how will your team collaborate on this? How do we prevent one developer from overwriting another developer's changes in production?
This is a governance question, and in Fabric, the answer is Git integration.
How does that work in practice?
It's actually surprisingly slick. You connect your Fabric workspace directly to a Git repository in Azure DevOps or GitHub. Each developer can then work in their own separate workspace that's connected to their own feature branch in Git. When you hit Save on a pipeline or a notebook in the Fabric UI, it doesn't just save it in the service. It serializes the definition of that item, the JSON for the pipeline, the code for the notebook, and commits it to your Git branch.
So you get source control, you can do pull requests and code reviews.
All of it. You get a full change history. You can see diffs, who changed this timeout setting on the copy activity. It brings true, disciplined software engineering practices to data engineering work, which has historically been a bit of a Wild West.
And what about promoting those changes from development to production?
For that, Fabric has a feature called deployment pipelines. It's a visual interface where you can define stages, typically dev, test, diff, prod. You can see the differences between the environments and then click a button to deploy your changes from dev to test. And the system is smart enough to use what are called deployment rules.
What's a deployment rule?
It's a find and replace for your connections. It means you can set a rule that says, When I deploy this pipeline to the test environment, automatically swap out the connection string that points to the dev SQL database and replace it with the connection string for the test SQL database. This prevents you from ever having to manually edit a pipeline in a production environment, which is a huge source of errors.
Okay, finally, we've got to talk about the question that matters most to the business. The bottom line, how much is all of this going to cost?
Fabric's pricing model is based on a shared pool of compute called capacity units, or CUs.
But not all of the operations we've discussed consume those CUs at the same rate. Break down the economics of a typical pipeline for me.
There are two main meters you have to be aware of. First, there's orchestration. This is the thinking part of the pipeline, running a lookup, setting a variable, looping. This is extremely, extremely cheap. It costs about 0.00056 CU hours for each activity run. We're talking fractions of a penny.
So the logic is basically free.
Practically, yes. But the second meter is data movement. This is the copy data activity. This is where the real cost is. It consumes 1.5 CU hours for every hour the copy job is running.
Whoa, okay, that's a monumental difference. 0.0056 versus 1.5.
It's several orders of magnitude different, and this is the point that connects everything we've talked about today. This is why we use shortcuts to avoid running a costly copy activity at all. This is why we obsess over the incremental load pattern to reduce the duration of the copy activity from hours down to minutes. If you run a full load every night that takes 4 hours, you're burning 6 CUs every single day just on that one pipeline. If you implement an incremental load that runs for 5 minutes, you're burning a tiny fraction of that.
So when you explain the watermark strategy in an interview, you're not just demonstrating your technical chops. You are explicitly demonstrating that you know how to save the company a significant amount of money.
Bingo. That is the business value answer. That's the answer that gets you from technically qualified to we need to hire this person.
This has been an absolutely incredible deep dive. We've covered the whole spectrum. Let's bring it all home. Let's summarize that ideal interview persona we've built today. Who is the candidate that walks out of that technical screen with a job offer?
The successful candidate, the one who gets the offer, is someone who can articulate that they build solutions using the medallion architecture on OneLake. They leverage shortcuts to avoid data movement and rely on Delta Lake for transactional reliability. They know the difference between data flows for self-service shaping and pipelines for robust orchestration. They can securely connect to on-prem data using the gateway and can even name the firewall endpoint. They use notebooks for complex custom logic, and crucially, they parameterize them for reuse. They implement the incremental loading watermark pattern to optimize for both performance and cost, and they wrap that entire development lifecycle in proper governance with Git integration and deployment pipelines.
That sounds like an absolute rock star data engineer to me.
And I would hire that person on the spot, no question.
Before we sign off, leave us with one final provocative thought, something that shows we're thinking about the future, not just what's possible today.
Okay, here's one. We talked a lot about maintenance and optimization. In the world of Delta Lake, historically, data engineers had to periodically run manual maintenance commands like VACUM to clean up old unreferenced files and optimize to compact lots of small files into fewer larger ones for better query performance.
Right, the janitorial work of data engineering.
Exactly. It's important, but it's not value-add work. Fabric is now rolling out a feature called predictive optimization for Delta Lake.
And what does that do?
It uses AI to analyze the usage patterns of your Delta tables. It watches how frequently data is written, what the file sizes look like, how the data is being queried, and then during idle periods of your capacity, it automatically runs those maintenance operations for you behind the scenes. It decides when the best time to run optimize is. It figures out the optimal file size for your specific workload.
So the system is starting to optimize itself.
It is, and that raises a really interesting and maybe slightly scary question for our listeners. If the system starts to maintain itself, what is the future role of the data engineer?
What's the answer?
The role elevates. You stop being a maintainer, a plumber who is constantly just keeping the pipes clean and defragmenting the drives. You become a true architect. Your time is freed up to focus on designing better business logic, building more valuable data products, and defining the overall data strategy for the company. You move up the value chain. That is the real future of this profession.
That is a powerful place to end. You're no longer just a plumber. You're an architect. Go get that job. You have the blueprint now. Good luck on the interview.
Good luck. You've got this.
Thanks for listening to The Deep Dive.